Hey guys, adding, subtracting, and multiplying polynomials. Not necessarily a difficult lesson as long as we pay attention to where we place everything. We have two additions, two subtractions, and we'll move to multiplications, okay? Let's do the additions first. Remember, when we add or subtract polynomials, we can only add the same type, so they have to have the exact same exponent. So here's your two polynomials. I go like this, and I go 3x to the third plus x to the third. I get 4x to the third. 2x to the second plus negative 10x to the second. They have the same thing. This becomes negative 8x to the second. Why? I just bother with the coefficients. Plus 2 minus 10, 8. Negative 1x plus, and you can put these here at 0x, just so you have it there, right? That becomes negative 1x, because adding 0 doesn't change anything. Negative 7 plus 8 plus 1. So you just go exponent by exponent or type by type. We do apples and apples and oranges and oranges. When they're put like this, they're easy. When they're in a line, they might get a little bit complicated. So we're going to look at this. 9x to the third. That's the only one I have, so that just stays the way it is. And I can cross it out. I used it. The next exponent would be to the second. I don't have one in here, but I do have one in here. Plus 5x to the second is the only one. I can cross it out. I'm moving to x's. I have a negative 2x plus a 12x. This becomes a positive 10x. They're the same type. I crossed them out. A positive 1 plus a negative 4, a negative 3. I have now add everything. So remember, we only can add the same kind. If there's only one of a kind, we just copy it, right? That was the case with 9x to the third and 5x to the second. When we subtract, it's not that complicated. It seems complicated, not that complicated. And the way I taught you in class, and I taught you last year, is make this a positive and change every single sign in here. Okay? So your parenthesis gets all of the sign change. That becomes a negative, that becomes a negative, that becomes a positive, that becomes negative. We flipped all sides, and now we're back to adding. We've done this before. 8x to the third plus negative to the third, 6x to the third. Negative 3 plus negative 6, negative 9, x to the second. Negative 2 plus 1, negative 1x. Positive 9 plus negative 1, positive 8. So once you change the signs, you just add them, right? And it's so much easier to add them that way. What happens when we have it like this? The exact same way. My advice for you would be do the exact same thing. 2x to the second plus 3x. I change that to a plus, and I change every single sign. Negative 3x to the second minus x plus 4. And now I just go type by type. Leading coefficients, x to the second. I have 2x to the second minus 3x to the second, negative 1x to the second, plus 3x plus a negative 1x plus 2x. I'm done with this. I only have 1 4 there, so I'm going to copy it, plus 4. And that's how we add polynomials, okay? Multiplying polynomials is going to be a little bit more challenging. And we are not going to do it the way they do it in the book in example 2. We're going to move directly to example 4. Example 3 we're not going to do. We're going to do example 4 directly, because I do not need you to multiply polynomial the way you would do long multiplication, okay? I feel we're going to lose a lot of time and get confused. Here's what we're going to do. And I am going to use two colors. Hopefully it's going to work. That's what they did it in the book. Okay, I have. I'm always going to write the longer polynomial first. They do it the opposite way. I like the longer polynomial first. So I'm going to do 3x to the second minus 2x. Can you see this? Yes. Minus 4. Oh, minus 4, sorry. I'm going to close my parentheses. Times in the red x minus 3. And the way this works, let me put the black down because I don't need it. The way this works is we distribute, guys. We distribute one by one. So this becomes, I'm going to use the red, I don't need to, but this gets distributed to this parenthesis. So this becomes 3x squared times x minus 3. Then minus 2x, it keeps its sign, times x minus 3. And then negative 4 times x minus 3. So what I did is I took that one and distributed, then I took this one I distributed, and then I took this one. Why? Because we've already done this. We know how to do this one by one, okay? The quality of the writing is not the greatest there. So I'm going to switch to black so make sure that you know what I'm writing here. Now that we did this, this becomes simple distribution. We've done this many times. This becomes 3x to the third. Why? This is a 1 here, right? So 2 plus 1, 3. Minus 9x to the second. And I'm done with this one. I'm moving over here. Minus 2x squared. X times s is x squared. Plus 6x. Why is it plus? A negative times a negative or positive? I'm done with this. Minus 4x plus 12. You know, this is the same distribution we've done every single time. The only key here is to distribute your exponent correctly, right? And now I just get the group. X to the third, I only have 1. 3x to the third. I'm done with this one. X to the second, I have 2 of them. This becomes negative 11x to the second. Negative 9 minus 2. X's, I have 6x minus 4x plus 2x. I'm done with these. And plus 12. So when you multiply like this, it is a lot easier if you just put the bigger exponent, or the bigger parenthesis first, and you take this one and you distribute it to each one of them. Okay? And then you do the multiplication correctly. What if we have to multiply 3 binomials? You have x plus 1, x minus 4. I think I switched the signs. I did. This is a minus. This is a plus. Then I'm going to times it by x plus 3. Well, the first one, I'm going to put a line over here. The first one is FOIL. We know how to do FOIL, right, guys? We know how to do FOIL. First, x squared, outers plus 4x, inners minus 1x, last minus 4. And all of it gets times by x plus 3. Let's group these before we do anything else. This becomes x squared plus 3x, y, plus 4 minus 1, minus 4. All of it times x plus 3. And now we're right back to where we started. This becomes x squared times x plus 3, plus 3x times x plus 3, x plus 3, minus 4 times x plus 3. All I have to do is do the distribution correctly. This becomes x to the third plus 3x to the second plus 3x to the second plus 9x minus 4x minus 12. How did I do this? Each one of them gets distributed, right? Please remember, this is a negative 4. When every time it's by a positive, you get a negative, right? This is where I foresee the most problems for you is the signing situation on each one of them, okay? And the last step I need to do is group them together. I only have 1x to the third. I have 2x to the second plus 6x to the second. They're gone. 9x minus 4x plus 5x. They're gone. Minus 12, and that's where we got when we did this. Now, on page 339, and I'm now going to write them on the board, you have special product patterns. 2 of them we already covered. We did the sum and difference. We did the square of a binomial already. The new one is the curve of the binomial, and that is really the cubic formulas. Okay, those are the ones that we're going to use probably the most. And they're new. We've never learned of this before. And I lied. I will write them in here so you'll know what it is. A plus b times a minus b equals a squared minus b squared. If you want to skip me doing this, fast forward a little bit. A plus b all squared is a squared plus 2ab plus b squared. A minus b all squared is a squared minus 2ab plus b squared. The new ones are your cube, the binomial, which is a plus b all to the third power, and a minus b all to the third power, okay? Those are the newest one that we do. And this becomes a to the third plus 3a to the second b plus 3ab to the second plus b to the third. So if it's a positive, everything is positive. You don't have to worry about it. If it's a negative in the middle, they alternate. It's the exact same formula, but the signs alternate. The first one is a positive. The next one is a negative. The next one is a positive. The last one is a negative. These are your formulas, okay? This is where we are. And right next to all of them, you have an example. Page 339. Let's look at 4 n minus 5, 4n plus 5. Well, I look at this and it's this. Same terms, different sides. So this becomes 4n all squared minus 5 all squared. Or 16n squared minus 25. How did I know to apply that one? Well, they're the exact same terms, but the inside of the parentheses are opposite. That means it's my difference of squares, right? Oh, yeah, it's a difference of squares. Now, let's look at another one. What if we do 9y minus x squared and all of it squared? Well, this has a minus. This is this formula right in here. So this becomes a, or 9y, all squared, minus 2 times 9y times x squared, right? And plus x squared and all of it squared. If this helps you in any way, go ahead and go a is 9y, b is x squared. And that way you know how to plug it in everywhere where you need to. Okay? So this becomes 81y squared minus 18 x squared y plus x to the 4th y. That becomes multiplication there, right? This just got distributed, and that's your answer to this problem. What if we have ab plus 3 all to the 3rd power? Obviously, this is a cube binomial. If it helps you again, go a is ab and b is 3. That way you can just substitute. So this becomes ab all to the 3rd plus 3 times ab to the 2nd times 3 plus 3 times ab times 3 to the 2nd plus 3 to the 3rd. I literally just went wherever was a, I put in a. Wherever was b, I put in 3, and I substituted. The last thing we need to do is the math. This is a distribution of exponents, right? So this is a to the 3rd, b to the 3rd, plus 3 times 3, 9. A to the 2nd, b to the 2nd, right? We distributed the powers. This becomes a little bit trickier where I have a 3 times a 3 to the 2nd. That would be 9 times 3 plus 27, AB, and then plus another 27, and that is your final answer. Right? Also, if you're wondering why it's different than the book, is because the book was AB plus 2 and I made the 3. So this is the right answer for that being 3. That's how we apply different problems. Now, we have 2 word problems in the book. I'm going to ask you to pause your video if you need to right now and read the words of it. I'm just going to write what we need to do and do it using a calculator, okay? You have the gross farm income G, and then you have the farm expenses, and they want to know what is the income N from this year, which means you take your expenses and you minus it from your gross income and you get your net, right? So I would have to do negative 0.246 t to the 2nd plus 7.88 t plus 159. And now I have to minus my expenses, right? My expenses are 0.174 t to the 2nd plus 2.54 t plus 139. And this is only for you to remember, whenever we minus 2 polynomials, I always told you change this and change every single sign in here. If it's a positive, make it a negative. In this case, everything becomes negative. Now we add them. We're absolutely going to use a calculator, and I'm absolutely cheating at this point. And I am going ahead and copying this. This becomes 0.402 t to the 2nd plus 5.34 t. Oh, I did it good. And then plus 28. Okay. So in order to find a net income, you take your gross income and you subtract your expenses. There's what you need to do. Okay, it says write a model for that income, you have it. And then the second problem that you have is multiplying 2 polynomials. Again, they are really, really nasty decimals. And if I'm not crazy, I do not think I gave you that as a homework. I don't remember now. But I'm not going to solve this again because it's really just multiplying, okay? So I would say you write the first polynomial first, you put the second next to it, and you just distribute. You use your calculator big time to find all of those decimals. Make sure you write your signs right, and you get your answer out. But that's basically how you do that other word problem. Are you wondering why you have to multiply? It's because they're telling you this. They're selling the number n of books, and the P is the price per book. They want to know how much money they made altogether. So you times the number of books you sold times the price for each book, and you get the number of books that all the money they made selling those books. And that is 6.3. Good luck with your homework.